Good morning, all. I'm audible to you guys, right? Okay. That new student নতুনজন এতিয়া অহাই নাই ন?
নাই মেম।
So, so today we will start the stack. It's in the module 2. চবকে কাম এটা দিছিলো মনত আছেনে? I asked you all one task. Let's see control. PUBG then मतलब क्या है? क्लास में PUBG खेल रहे हो क्या? वैसे PUBG फिर भी मैं ले लेती लेकिन वो एग्जाम्पल नहीं है स्टैक का. Anyone remember the task? Okay, let's share my screen. Yes, other example of step, correct. So, anyone wants to tell? Not anyone actually, all of you have to give me at least one example, like your real life example, where you can see there is kind of like stack data structure. So, who wants to give me one example first? So, last in, first out, कहाँ कहाँ पे होता है? कोई भी day to day life work हो, anything. Where can you see that pattern? The last thing will go in will be the first one to go out. So true, so true. Okay, I just share my screen for your reference. So what was that? It's simply a collection of similar data types and it is always in a ordered list and it has a predefined capacity and it has a particular way through which you can add or remove items, and stack is specifically your last in first out. That means the last element or last thing that you will put inside a stack will be the first one to go out, or you can also say the first one, first in and the last out. So one example I already, yes, this one I already gave example, like the pile of plates or your disk. What Others. Books in a bundle. Okay. And other. Where can you see that pattern? Last in, first out. Pile of dinner plates correct. Books in a bundle is also correct, provided that it's just a pile. Then others. Chair which were putting one by one. Very good. This is a very good real life example. The chair thing. Then others. Any more? Girls. Girls want some example from girls. जिसको ज्वेलरीज पसंद है, maybe they can answer. Roti in hot case. Okay. The plates is a common example, whether it can be in canteen or dinner plates or anything. Other than that, you can say the bangles for girls. When we wear bangles, then we just put it one by one. Then again, when we put it out, then we just take it one by one. So bangle is another example. Just wait a minute, something like that. तुला कुछ खाया नहीं मैंने तो खाया कि नहीं Okay. So okay, the bangle is another example. One time bundle of one time plate. Okay, plate is a common. Whether you keep your plates in a canteen or dinner plates or anything, plate is still will be the same example. You are just telling one example with in like with different conditions. Think more. Okay, can you say when we undo things, what should be the data structure they suppose while typing something, we always click undo button, right? So can you relate how undo button works now? Undo button, what it does, it simply reverse your process, correct? So what happens when you click the undo button? Answer. Any other examples? No more. What happened to girls? Is it any examples? Others? A4 size papers. Yes, that's the correct one too. Very good. Okay, so I guess enough example. So like chat paper, chart paper, or not chat paper. Okay, so ticket counter line. Okay, that is also very good example, ticket counter line. But the thing is, ticket counter line that is not stack, that is queue. Who gave the ticket counter one? टिकट काउंटर में क्या होता है जो फर्स्ट जाता है वो लास्ट में that one is correct but that one is not stack that one is queue data structure will go to means later yeah okay so stack is simply the last in first out data structure so next there are certain operations you can do in stack so later so what happens in stack if you can remember these type of data structures are known as non-primitive data structures, correct? That means these are derived data types also you can say. So your basic or primitive data types were like float, boolean, int and all. So this stack and other data structure you can implement with the help of other data structures like array and string and all. So in all the data structures, we can do certain types of operations. Remember, we learned about certain operations on data structure. Those are your traversal, add, delete, remove, then stack or copy. Okay, that one is correct too, Rohit. Okay. So in this type of data structure, you can just simply think about your empty vessel or your test tube or just think about the state means shape is will be like this where one side is open the other one will be closed because you're adding and removing item will be just from one end only okay so the operations mainly in stack are push pop pick and is empty push means you are adding an item in the stack okay then pop means you are removing an item from the stack. So if you are talking about inserting or deleting element or item in a stack, you are going to say that it is a push or pop operation. Push means you are adding an item, pop means you are deleting an item in case of stack. Then there is another function which is P or top. What it does, it simply returns the top element of stack. Then there is another function is empty. So is empty function just checks whether the stack is empty or not. Then there is another function which is full. So just like is empty, the other function is full. So is full will simply check whether the stack is full or not. Now let's see here. This is an empty stack. Here first you want to add 1 into your stack. So you will simply push 1 the value into the stack. Then you are adding another value into your stack. Okay, then you are pushing another value. Then when you want to delete an item, so your top element will be deleted from your data structure. So only element that we are really wants to see is your top element because your adding and deleting is only happening at the top one. So when you are using a stack, you can see only one element and that is the top element of your stack. Now, the top repeat. Okay, top means you are just checking the top element. Suppose in this stack, In this push, suppose in this push operation, what will be the top of your stack? It's 1 because there's only one element. In this case, what will be the top? Is the 2. This is the last element we have inserted in the data structure. So top value is 2. Okay. So just think about an empty vessel or suppose your bottle. So बोतल में तुम कुछ भी घुसाते जाओगे या कॉइन्स होगा या कुछ भी होगा सो फर्स्ट जो रहेगा यू कैन सी ओनली दैट थिंग राइट so it's just top element. And suppose, for example, bottle is like it's not transparent, so you cannot see through the bottle. So just think about your non-see-through bottles, and you are just adding items into your bottle or a vessel. So you can see only the top element of the bottle only. And since it's not transparent, you cannot see what are the other elements inside your bottle. Are you getting the point now? Is it clear? Okay. Now, अभी मैंने कहा suppose your bottle is not transparent, correct? Since your bottle is not transparent, that means you do not know what is inside your bottle, whether your bottle is empty or not. Okay. Now, for example, suppose your that vessel is not empty. Okay. That means there is already something inside your bottle or vessel. So in that case, whenever you are going to add one item to the stack, you will always check whether something is inside the stack or not. You will always check whether the stack is empty or not. For the initial adding, it's a condition, means the stack must have to be empty. Okay. Now, when you want to delete an item, again you will check whether the stack is empty or not. That time you will mainly check the isFull function. isFull will check whether, okay, let me add here. Just like isFull, there is another function is full. So it will simply returns full if stack is full. Okay. So this function will tell you whether it's full or not. So is empty, you will only check when you want to add some item. Why it's important to check if it is empty or not? Any guess? Why it's important to check it's empty or not? Any guess? And why it is important to check whether it's full or not? Okay, अभी बोलो suppose again same situation, you have a non-transparent bottle and you are adding water into it. Okay, now you don't know और कितना पानी भराने से it will be full. Correct? If you keep adding water into your bottle, what will happen? What will happen if you keep adding water into your bottle? You cannot see how much it has full. Yes, correct, Deepa. It will overflow. Why? Because your bottle has a limited capacity. So when you will add more water, your water will simply overflow. So same thing will also means applicable to your stack. If your stack is already full and still you are trying to add some item, then it will be a overflow condition. Okay. And there is another condition is underflow. Suppose there is nothing inside your bottle, okay, and still you are trying to delete the item. If there is nothing to delete from the bottle, or means empty, then that will be a underflow condition. So you have to always check the overflow and the underflow condition before pushing and popping an item. Is it clear? Overflow. When will it be overflow? It's already written in the slide, but still. What is the condition? It's already in the slide, but why we need to check this overflow and underflow condition? Is it clear to you guys? Yes, no, anything. If you have condition, means confusion, just tell me again. Okay. Yes, yes. So, okay, I move. So now we will check the algorithm for push operation. Push means what? You are adding an item. So whatever operation you want to do in the stack data structure, it will only involve the topmost element in the data structure. Okay. So for push operation, you will always check first whether the stack is full or not. You want to add some item into your stack. So before adding, you have to check whether it is full or not. If it is full, then if you are trying to add one more thing, that then it will create a overflow condition. So after checking whether the stack is full or not, then if it is full, then it will simply print it is overflow and it will not going to add any more item. Now if the stack is not full, then it will simply add the element. So for stack operation, we keep one pointer, not pointer, it's, yeah, you can say pointer also. It's just an element top. Okay, this top word will specify the topmost element in your stack. So whenever you will add one item, you will always increment the value of top before adding the item. Top will simply show you whether your stack is empty or full, because based on the location of top, you will get to know the capacity of your stack. Okay. So next come your pop operation. Pop means deleting an item. So before deleting also, you need to check whether stack is empty or not. If it's already empty, there is no point of popping an item, right? Because there is nothing inside your stack, so nothing to delete. Therefore, it will simply return the underflow condition. And if there is something inside your data structure, it will simply remove the top element from the stack and it will decrement the top. Is it clear to you? Is it okay? Hmm. Okay. Okay. See in the picture also you can see the top will be maintained. Then even if your stack is empty, it will simply check whether it's empty or not. When you want to push one element, suppose you are adding one, it first top will be like -1. For example, initially we set the value of top as -1. Then when we will add one item, here I'm adding one, so it will be in the bottommost. Then you will increment the top value as 1. Okay, next you are adding another one, then again you will increment the value of top. Yes, yeah, that, how does it work? So we will always keep a pointer top to keep track of the top element of the stack. Why we do that? Because we are only concerned about the top element. Because what is inside the stack we cannot actually see because it's non-transparent and we cannot see what's inside. So we can only see the top element. Therefore, we always keep track of our top element, and for that we will always initialize the value of the top. So in the initial state, we will simply set the value to -1 just to check whether stack is empty or not. If you can see the value for top is -1, that means your stack is empty. That means you can add item to your stack. Now on pushing an element, we will simply increment the value of top and place the new element in the position pointed to by top. Then again, when we want to delete something or copying an element, we will simply return the element pointed to by top and reduce its value. And before pushing, we will check whether stack is already full. And before popping also, we will check whether it's already empty. So you can see the whole process here. Initially, our stack is empty. So the value for top is -1. Next, we want to push one item into the stack. So when we are adding an item into the stack, we will increment the value top. So after incrementing the value, the top value will become 0 and we are adding 1 into your stack. So your first element is 1. Next, we are adding another element. So before adding that element, we will again increment the top value. Now in the second push condition, your top value is 1. Then you are simply adding the item that will be your second position. Then again, suppose you are adding another item, then again you will increment the top value and simply push the value inside the stack. Now when you want to delete the item, you will decrement the top value. Okay. Whenever you want to pop item, first you simply decrease the top value by 1. See, from 2 it becomes 1 in the pop operation, and you will simply remove the item from the stack. Is it clear how it works? Is it clear to all? सबे बुझी पाइছানে? सबको समझ में आ रहा है? Once again explain it. डुलर कौन सा पोर्शन एक्सप्लेन करना है फिर से? होल्ड पुश एंड पॉप or just one part? Second point. Second point means popping one. Is it popping one, Dular? Second point means -1. Okay. Yeah. So just wait a minute. Oh, first place. Okay. So sorry. So when you will add an item to the stack, you will just increment the value. This one is clear, right? So initially when your stack is empty, your top value will be -1. Whenever you will add an item, you will simply increment the top value and add the item. So when you want to decrement means pop an item, you will decrease the value of top. Suppose in this case, this particular case, your top value is 2 and you have 3 items inside your stack. Okay. So when you want to delete something, first you need to decrease the value of top. Okay. So when you want to delete, simply decrease the value by 1. So in this case, top value is 2. So if you want to delete, decrease it, and now your top is -1. Then you will just delete the item. No hassle. So if you want to add item, increase the top value by 1. If you want to delete an item, decrease the top value by 1. Is it okay now? Okay. Anyone else? Any confusion? Just remember the shape. Your stack is like your non-transparent bottle. You don't know what is inside. You can just think about your that chips, Pringles. Yeah, Pringles. It's a cylindrical one, right? You can just take one chips at a time, correct? You don't know how many chips inside your. Okay, ma'am. If we add four instead of two, you cannot put more than one item at a time. Okay, you can simply add one item at a time. You cannot put more than one item, and you cannot delete also more than one item from the stack. It will be always one processing. Okay, ma'am, in simple word we have to decrease top value with one. Yes, correct. Simply decrease by one. एक ही step है. So if you want to add item, increment the top value by one. If you want to delete an item, then decrease the top value by one. That's it. Very simple. So just think about, remember your Pringle chips, uh, that thing. I guess all of you know the Pringle one, right? Pringle chips किसने खाया? सबको पता है ना? Pringles का पैकेज कैसा होता है? Yes. Okay. Yeah. Just remember that one. You can see only the topmost chips. When you take the topmost chips, हाँ मैम खाते हुए देखा किसी को, हाँ तो देखा मतलब देखा ना पैकेट कैसा है, वो सिलिंड्रिकल जैसा है. तो तुम सिर्फ फर्स्ट वाला चिप्स ही खा सकते हो. वंस यू फिनिश ईटिंग योर फर्स्ट चिप्स देन यू कैन गो टू द सेकंड चिप्स. ओके. और तुम वो बोतल में यू कैन नॉट पुट मोर चिप्स, नहीं तो आइडर सब टूट जाएगा, नहीं तो वही ओवरफ्लो हो जाएगा. और if your bottle is mean that package is already empty, you will not get any chips, right? So just remember that package. So simply, if you want to add item, increment the top value by one, and if you want to decrease an item, you are going to simply decrease by one. And we are only concerned about the top element because we can see only the top element, right? We cannot see the others, correct? Or CD box भी same है. That's where you keep all your CDs. You can just put one CD at a time, right? And you can see only the topmost CD. If you want to see what are the other CDs, you will just take out one by one, correct? So just remember that thing. So now you tell me what will be the complexity for adding an item. For pop, what will be the time complexity? Guesses? Any guesses? Time complexity for push क्या होगा? Pop क्या होगा? We are mainly concerned about two things. Is empty, is full, and big. So what will be the complexity? It's very simple. Just think a little bit, you will get the answer. Okay, once it the one, then others, others. Abdullah said it's one. Others, think a bit. Okay, you said one for pushing. Okay, I'm noting down. Then others, what will be the time complexity for push pop? Noun. Okay, just tell me about the push one. What will be the time complexity for push? You are adding an item. What should be the complexity? O N. You said O N. Okay, others? Others? बोलो क्या है? Dipa, Imomlen, it's O one for pop. You said one for pop. Okay, for push operation per se. So for everyone, for 2% said pop is O1. For push, you said O1. Okay. Others, Lexi Singh, बाकी चीज में तो आंसर देते रहते हो बोलो. For dollar, push is ON. Okay. For push is O1. You said project. Then others. Okay. I'm telling you. For all the operations, time complexity will be simply O1. Why is it? It's not ON. For all the operation, complexity will be simply O1. And why is it? Okay, I already gave you the answer. The time complexity for all the operations will be O1. Now you tell me why it's O1. I guess that. Okay, go on. We are adding and removing one by one. Okay, the other answer. Others, why it's just O1 for all? Because all steps are done one by one. Okay, similar answer. No idea. Okay, okay. Deepan Abdullah is actually because it's empty. This case, okay. Operation takes constant time. Okay, go on. Deepashri and Abdullah is kind of correct, and you two are correct actually. Rojit is also correct. It's a constant time. So you can see in case of stack, you are only dealing with the top element. Everything happening is just one step, right? Just in one step you are doing everything. One step you added an item, one step you are deleting an item. So all the operations are involved only with the top element in the stack. So all of these operations involve just one step. Therefore time complexity is simply O of 1 for all the operations. Is it clear? Is it clear to all? Why? Yeah, okay. It's clear to all, right? So for all the operations, it will be simply O1 because it involves simply one step. And search operation will be ON. Why is it on for search? Why is it on for search operation? Suppose you have added lots of item inside your stack. Now you want to find a particular item in that stack. And for searching, it's on. Why is it on? Just think a little bit, you will get the answer. Why the complexity for search operation is on? Because we may need to check the last item. Okay, yeah, it can be the last item. We don't know in which step we will get. Okay, because there are an items. Yes, all of you are kind of correct. So instead, what will happen? If your item is in the last position, you cannot find that item until you pop out all the elements from your stack. There are n number of items from your finder. Yes, correct. So there are n number of items in your stack, and you cannot access all those elements together. It's more like a linear search, isn't it? Linear search means you are searching an item one by one. In the searching, first you will check to the first element. If it is not the element, you will pop that element. If it is, okay, just go here. Suppose you have your stack here, then 20, 2, 5, 6. So now you want to search, for example, 20. Okay, or for example, you want to 10. Now, only item you can see is your top element, and your top element is say here, and you want to search item 20, and you do not know what is the location of it. So it is simply your linear search. You will go sequentially. You will first see your top element. It's not the item you are looking for. So you will simply pop your top value. Okay. Next, your item is 5. Okay. You will again see whether target is equal to 5 or not. It's not. So you will simply pop this element again. Now your top is 2. Again 2 is not equal to the 10. Then you will again pop it. Now your top element is 20. If you are looking for 20, then you found a element. And if you are looking for 10, then you will again pop this item, then finally go. So here also you are going sequentially. It's a linear search. And in stack, you can access only one item at a time, and the one item is your top item. So for searching, you have to go through all the elements, or at least n elements in a stack. So it's a linear search. Time complexity will be simply O(n). And for any other steps, mainly the push, pop, and others, it's just one because it's involved just one step. Is it clear to you all? Is it clear? It's going to answer. Okay. Okay. I can share the slides. You can go through it later. I stop sharing screen and see your attendance. Okay, so I hope it's clear to all of you. It's the simplest data structure stack. It's like your CD folder or your Pringle chips case. So you can just eat the topmost chips only, or you can only take out the topmost CDs only. So adding an item or removing an item, it just involves one step, and you will always check the top element. So whenever you will add an item, you will increment the top value by 1, and whenever you want to delete an item, you will simply decrease the value of top by 1. Okay, increment by 1 and decrement by 1. If increment means adding, if decrement that means delete. And you before adding, you always see whether the stack is empty or not. Okay, and for deleting also, again you will check whether it's full or empty or not. So you have to check overflow and underflow condition. Overflow condition you will check when you want to add the item. If your stack is already full, you are not going to add any more item because it will simply overflow. And underflow condition you will check only in case of popping an item, because if there is nothing inside your stack, there is no item to delete also, then it will be a underflow condition. Okay, so that's all for today. Next class we will see the application of stacks. Okay, so thank you everyone, I'm ending the class now. Anyway, it's going to cut very soon. So bye, see you in the next class next week.